Hello everyone, welcome back to my YouTube channel. Myself Grishma. I am pursuing my BE in Sri Venkateswara College of Engineering. Today's course title Operating System, course code BCS 303, topic Introduction to Operating Systems. Contents that we are going to study in this PPT are operating system, types of operating system, virtual memory, memory management, deadlock, networking, file system, OS services. Operating systems. Operating systems. The operating system is the most important program that runs on a computer. Operating system is an interface between computer and user. It is responsible for management and coordination of activities and the sharing of the resources of the computer. Operating systems, user, application, operating system, hardware. Types of operating system: real-time, multi-user was a single user, multitasking was a single tasking, distributed, embedded. Real-time operating system is a multitasking operating system that aims to executing real-time applications, responds to input instantly. Multi-user was a single user. Multi-user operating system allows multiple users to access a computer system concurrently. Time-sharing system can be classified as multi-user systems as they enable a multi-user access to a computer through the sharing of time. Single-user operating systems, as opposed to a multi-user operating system, are usable by a single user at a time. Distributed. A distributed operating system manages a group of independent computers and makes them appear to be single computer. The development of networked computers that could be linked and communication with each other gave rise to distributed computing. Major functions of operating system are resource management, data management, job management, standard means of communication between user and computer. How fast is input and output hardware? These are the devices and the data rate of devices. Keyboard 10 bytes per second, mouse 100 bytes per second, printer and scanner 200 KB per second, USB 1.0 MB per second, USB 260 MB per second, hard drive 20 MB per second, PCI bus 500 MB per second. And this is the structure of input and output hardware, where we can see video controller, hard drive controller, USB controller, network controller, which is outside world. Common system components: process management, main memory management, file system management, input and output system management, mass storage management, networking, command interpreter, protection and security. Single versus multiple processor. Single processor can only run one instruction at a time. It gives the appearance of multitasking with switching. Virtual memory. Several programs can't fit in main memory, so what happens? Virtual memory is a part of active programs stored on hard drive. Example, I have got Windows XP running, MS Word, 3 Explorer, Windows 1 being active. Rather than not letting you open more programs, the OS will run them using virtual memory. 16-bit versus 32-bit. 32-bit programs use pre-imperative switching. 16-bit programs use cooperative switching and are more susceptible to freezing. Memory management. Strategies for obtaining optimal memory performance. Performance by memory manager. Which process will stay in memory? How much memory will each process have access to? Where in memory will each process go? Deadlock. Program A wants to copy from disk 1 to disk 2 and takes controller of disk 1. Program B wants to copy from disk 2 to disk 1 and takes control of disk 2. Program A must wait until program B releases disk 2 and program B must wait until program A releases disk 1. Programs A and B will wait forever. Deadlock Prevention. OS must have a systematic way of controlling program execution. This is very complex problem. One simple, not very efficient solution is to have programs timeout. In our example, program would timeout first and release disk 1 and try again shortly. File system. The OS must save files in a logical, efficient way. Hard drive, floppy disk through FAT, that is file allocation table. Recall FAT32 versus FAT16. 32-bit addressing means each section of memory is broken up into 2 raised to 32 individual addressing locations. Much faster to find a file. Examples of Windows and Unix system calls. These are some of the examples of Windows and Unix system calls. First one is process control. The Windows are create process, exit process, wait for single object. Unix fork, exit, wait. File manipulation, create file, read file, write file, close handle. And Unix are open, read, write, close. Device manipulation, read console, write console, set console mode. Unix are IOCT1, read, write. OS services, user oriented. Program execution. OS capabilities to load a program into memory, run it and execution either normally or abnormally. Input and output operation. Since user's program cannot execute input and output operation directly, the OS must provide some means to perform input and output, which may involve a file or input and output device. File system. Program capability to read and write, create and delete files and directories. Communication. Processors may exchange information on the same computer or between computers over a network implemented through shared memory or message passing. Error detection. Ensure correct computing by detecting errors in the CPU and memory hardware in input and output devices or in user programs. And this is the view of operating system services, where we have GUI, batch, command line, user interference, system calls. In system calls, we have program execution, input and output operation, file system, communication, resource allocation, accounting, error detection, protection and security. Thank you for watching my video. Please do like, share and subscribe.